there, YouTube. Welcome back. This is the Allegheny Northern in N scale, and today I want to go through a couple of things with you that I am learning, basically trial and error as I expand the Allegheny Northern. And so what I have in store today is two topics. One is distributed power, and the other is adding power districts and power management to your layout. So as we're watching here, you can see that I've got a coal train running. That's right, trains are running again on the Allegheny Northern. And although as of, I think it was 2 weekends ago now, we had no trains running, some things have changed in the last, week here, and made a little bit of progress. And so now that I've got trains running, I started noticing problems. And one of the key problems that I was noticing was, although my trains had previously been able to traverse the layout with no problem, with the motive power that they had on, now they were starting to struggle a little bit. And it wasn't that they couldn't make it up the hill, they certainly would. The issue was the cars were not staying on the track and behaving like good little trains should. So I started doing some experimenting with the trains themselves, and realized that the issue was not that I had insufficient motive power. The issue was more that I had bad distribution of motive power. And so it boiled down to a simple physics problem based on the grades that I've now introduced to the layout. So as we're watching here, other than that little spot of dirty rail that kind of stalled the train for just a brief second, you can see that my train is running very smoothly up the grades. It's not stuttering, it's not having any issues whatsoever, and I haven't added any more locomotives to the train than I've had before. But you will notice, of course, that I have a unit in the back. So while this train makes its run around the layout here, I'm going to show you where I was having issues. Now, because I'm running distributed power, these units have already been speed matched, and it helps that they are exactly 3 of the same model. So they're the same locomotive, they are the same make, and all released around the same time, so the gearing was pretty close. So speed matching was just a matter of making sure they ran together and no other adjustments. I do have a video on speed matching, so if you have any questions on what that is, you can tune into that video. I'll put a link in it for you. But what I was noticing is, so the train's coming down here now over the bridge. It had a fairly steep grade to come down. And once this train passes, I will show you that grade. And what was happening was, when I get to this curve, either right before it or right after it, I would end up with cars spilled all over the place. And as you can see now that the train is gone, I have no cars spilled all over the place. And I'm going to have you take a view right there. That's the grade. It's, I believe, I'm going from memory here, it's probably about 3 inches over the run of about 6 feet there or so. So it's a fairly steep grade. And what was happening was, all of the cars, the weight of all the cars pushing, was getting down here to the bottom. And they were forcing the trucks of the different cars off the rails. And yes, those Cato units that you saw running around do have a low profile metal wheel set, so they don't have quite the flange that a standard, say, microtrains does. But what was happening was, all of that weight was turning the trucks, and of course when they would hit the small little gap at the bottom of the bridge, everything would come off the rails, and I would end up with coal cars all over the place. So by solving the issue was rather simple, and I took a playbook right out of the real railroads, the 1-to-1 scale, if you will, and I added a distributed power unit. Now, it doesn't really matter where I add that unit, whether it's in the middle of the train or the end of the train. What I'm doing is I'm picking up some of the weight that is on the lead locomotive, so that all cars, in this case 24 of them, are not pushing against the front of the train. So there's, I'm keeping slack essentially in the couplers, and I'm also at the same time taking the centrifugal force of the curves and the grades off the train at its entirety, and I'm breaking it up into segments. So there's always a weight at the back of the train now, either pushing or pulling, depending on what the train's doing. So upgrade, this locomotive is pushing at this point to make sure that we've got enough oomph to get up the hill. And when we come down the hill, it's doing the opposite. It's providing a back check, basically, so the cars can't just roll with gravity. Essentially, the back locomotive is in braking more than anything, and it's pulling the train back. So what I'm going to do now is I'm going to stop the train and the video, and I'm going to actually put all of the power on the head end, and I'm going to show you what happens. Okay, so now we're coming around, and I've got the throttle set to the same speed. I only left the head end units on because I don't actually need the third unit to push anymore. We're coming downhill, so same throttle speed. I'm at 16 here on the 128 step throttle, and all of the weight of that train now is pushing against these two locomotives. So as you watch here, there's my first car off the track, and there's no sense in going any further because they're just going to keep jumping. So what was happening is all of that weight from those 24 cars was pushing back, and it was what was stopping it was the locomotive, because they weren't going as fast as the rest of the train wanted to go. And as you can see, I even got the locomotive came off the track. So the whole thing just doesn't work when I don't have distributed power and that much train behind it. So the question of whether or not I am going to need distributed power on the layout is pretty much answered, at least for trains heading in this direction. That grade coming down is just entirely too steep, and they need that distributed force to prevent a derailment. So what I'm going to do is I'm going to turn the camera off. I'm going to back the train back up. I'm going to put the distributed power back on, and then run back down the hill to show you that the first time was not a fluke. Okay, so while our train's making another loop, a couple of things that I wanted to point out for those of you running distributed power like I am now sort of almost forced to. First things first is it matters how you distribute your power. And you can find some different charts and whatnot online that will show you basically where the forces are in your train based on, where your power is, so and what forces you're cutting down. As far as the strains within the train. So if you want to understand the physics of it, that's available to you. But what you got to be careful of is putting a single locomotive on the front and two on the back is not the same as having two on the front and one on the back. So you've got to see how your train is handling and understand that you're always going to want more power on your front end or equal power. You're not going to want to have a bunch of cars shoving upgrade. It's just going to lead to a derailment because they're not really meant to be shoved in a long train. So keep that in mind when you're thinking about how you're going to distribute your power, and then from there whether or not you're going to have your helper units in the middle, or if they're going to be distributed power, or if they're going to be on the end and there's just something that gets tacked in or cut in. That's an operational thing that you'll have to decide. The other thing that you may want to consider, and I know it's something that I'm considering, is not having truck-mounted couplers. When you have truck-mounted couplers, instead of the forces on the train going through the body of the car that would happen, say, with a real train, you're putting all of that force on the wheel set now, and so you're pushing and pulling on the wheel set, and you're forcing the flange out of the gauge. So if you can get away from those and go body mount, that's the way to go. It's something I've wanted to do to the layout for a long time because I know it provides better operation. I just haven't done it because it was one of those things that, well, I didn't really need to. So that's something that I'm going to start undertaking here. And I know some cars are a little more difficult to do than others, so you may have to shim certain things and whatnot, but you really want to get away from truck-mounted couplers. And then the last thing is I know that some of you guys really like the low-profile wheels because they look better. And yeah, the low-profile wheels do look better, but they are more finicky and they are more susceptible to imperfections in the rail and imperfections just from a train being pushed, say. So I like the micro trains. I know that they're a little bit more on the unrealistic side, but for reliable operation, that wider flange just holds better. for me. And so you guys can do what you want. I'm not trying to start a battle as to who's right and who's wrong, but I go microtrains. Okay, so distributed power is definitely the way to go on the layout. Now let's talk about the next thing, and that is setting up different power districts and power. Okay, so in order for this section to make sense, you have to have a booster, more than one booster on your layout. So if you are like me and you're running a starter set and you have your command station and booster combined, mine is the Zephyr Express. There is multiple different versions. So everything that I have is Digitrax. Most of my decoders are Digitrax. All of my track components, from the Loconet ports to the auto reversers, I stayed all Digitrax. It's just everything works together easily, and I don't need to do any kind of different programming or provide any kind of different modules to interchange between systems. My choice. Whatever system you use is going to have similar features. So what I'm showing you here is this bridge represents two different power districts. So on this side of the track, we have the original Zephyr Express command station and booster powering it. And on this side, we have the DB, I believe it is the 210, powering this side. So the break where the gate swings here represents the break in the districts. And you can see that I've got little plastic pieces. They are super glued into the ballast and the rail there, and they have been filed to meet the rail profile so that the trains can pass over it. Because this is actually a swing gate, technically I probably didn't need to put the plastic in there, but the gap was just large enough that I wanted something else to help the train get over. So when you see the locomotive come up to it, the goal is that it goes seamlessly between the booster and the command station booster, and you'll notice there that there was no hesitation, and it had flowed right over. So there's a couple of things that will screw this up royally for you, and if you don't know what to look for, you may be surprised as I was. So I'm going to share this with you. First, you need to make sure that your booster is grounded to your command station. So as we come around here, and I know the place is a mess, so don't judge for the moment. There is a ground port that is on the booster. It's the white wire right here, and it simply runs to the ground on the command station. So those are balanced. Second thing you want to make sure, and I know this sounds silly, but you need to make sure that your right rail and your left rail are the same on both your command station and on your booster. If not, it creates a short. And if you go online, I know you can get very easily confused by whether it's AC, DC, polarity, yada, yada, yada. I'm going to keep it very simple without going into it. Your rails have polarity, but your rails are not positive or negative in DCC. So you need to get that sort of notion out of your head, because of the way the command station packets the digital signal and sends it out for the decoder to interpret. Basically, it's a modulation of the signal, and it happens in basically a cycle rate on your rails. So they need to be in line, and they need to be the same throughout the layout, or you'll get a short where they'll be offset. So although the signal's coming out the same, you've inverted it, and so when you cross over, you will get you'll get a short at the power joint there. Now, the very last thing that you've got to do when you're adding a booster to your system is you need to look at the voltage, and you can find that usually it's in the literature that you've purchased with your system, or you can find it online if it's not there. And so if your command station and booster are putting out, say, 13 volts, then you need to make sure that your booster for your other districts are doing the exact same. And in most cases, it might be different. So I know that by looking up that this little guy is putting out 13 volts to the track. And I know that my booster on startup was not putting out 14 or 13 volts. So there's what they call voltage trim. and if you grab your little handy-dandy instruction manual, it will go through here and it will tell you how to do that. And so just quickly getting through here, you will see that there is a whole section on adjusting the voltage trim. And there's also, you need to go into the op mode of the system here to get to that. So I'm going to show you what that looks like, and though I'm not going to make any changes. So I'm going to show you how to do that with this system, and then I'll explain to you what the difference is. So let me grab my throttle and we'll go from there. So once again, my system is Digitrax. I am running all Digitrax components. I have the Digitrax Zephyr and the Zephyr Express, and I've also got the 210 booster. And so what we're going to do here is, your book has what your normal output is for voltage. It gives you by scale. So we need to make sure that the Zephyr and the booster match in voltage. And I can tell you out of the package they did not. And so what was happening is, as my locomotive was coming to that joint that I showed you, where now it's running very smoothly across it, it was actually stuttering. So the whole train would kind of slow to a crawl as the voltage was passing between the two boosters through the locomotive and through the decoder. And so it would kind of stutter across it, and then when it was on either side, it ran just fine. But it was when it was crossing, and it didn't matter whether it was here at the bridge or at the other isolation point, and I was getting just getting this stutter. So when you read your book here, if you've got Digitrax, what you need to do is you need to drop this into op, and once you do that, it'll turn the track power off, and you'll see that flashing just like that. And then you need to go into here, and you need to get into the switch. So if you got your throttle and you just hit the switch here, you have various variables that you can change. And so in this case, it'll tell you what switch position you're looking at and which one you want to change. So I know for a fact that on this, by reading the book here, I want to go to 5 is what I want to change to adjust the voltage trim. And so just by simply hitting 5, and then the close button or the clock button, I am going to take it from the default, which is T, to the C, which is close. So that's open and close for your switches. For those of you running accessories, you already know that. So you would hit that, and then it would go into that mode. And then after you do that, and I'm not going to do it here. Actually, we'll go ahead and do it. That's fine. So now I've got, you'll notice that it went from, the 5 is now closed. And so what you have to do is you need to go into here and select, take one of your knobs, and you need to select a locomotive and make it 0-1 is your programming. And once you do that, this will start beeping to let you know that you are now in a voltage trim setting, and you can adjust your voltage trim by turning this throttle up and down. It will adjust to whatever you want your voltage trim to be. And so with the Digitrax, if you get outside of the range, let's say, it stops beeping. And so that means I'm applying too much voltage to the track, that I'm not supplying enough to the unit itself. So it'll begin beeping once you come back into range. So I know that for this unit and for the train to run smoothly, I need to be at about 28, and that aligns these two. Now, you could do a voltage check, and that's probably the way you should do it with a voltage meter. I did it by just by simply trial and error to get the locomotive not to stutter. And so after I've set that, then I just go ahead and I put it into run mode, and then I'm set and ready to go. It'll stop beeping, and then we'll go over and I can show you the difference here. Okay, so what I did is I went back and I reset my voltage trim here so that it's at 0. And see how the locomotive kind of stalls there, and when it's spanning both sets, and you kind of hear that little bit of a ringing noise It's just because it's trying to balance between the two phases. And so what we'll do is we'll go back and we'll retrim the voltage. So back at the booster here, we're going to go ahead and go into op mode. And we're going to wait for the flashing, which we have. Then we're going to go into our switch here, and we're going to go into 5. Now each time you go back into 5, it's going to go back to closed. And if I didn't say this, and I meant to, you need to be plugged into your actual booster. You can't go to a remote LocoNet port. You've got to be into the booster itself for this. So we're going to go ahead and we're going to close that switch. And now that that's closed and the unit has recognized it, we're going to go back and we're going to hit Loco, and we're going to set the address to 01 for the programming. Tell it that that's what it is. And you're going to hear our unit flashing here. And so I'm going to go ahead and up my voltage. Like I said, I already know what the number is, so I'm going to go ahead and set that to 28. Now, when you go ahead and you put this into run, it's automatically going to remember that that's your voltage, and that's what it's going to keep. So we're going to go ahead and set that into run, and we are now set and programmed and ready to go. So we'll go back over to the locomotive, and I'll show you. Okay, so now we are just running the locomotive over it, and you'll notice that it doesn't stutter, it doesn't stop, it just rolls right through. In this case, the difference was subtle. I was having some other locomotives that would basically violently jerk stopped as it went through. But you can see that we're not losing any kind of speed coming over here now, and it's just riding right over. So I've got the voltage much more in line, and that's what you want, because obviously you don't want that voltage to pass through your locomotive. So if you've got any questions on that, I know I kind of went through it fast. It was a sort of a afternoon of reading and trying different things, but I figured if I didn't know you needed to do that, then there's chances somebody else out there doesn't know you need to do that either. And so make sure you're grounded. Double check your wires. I think that goes without saying. Then, of course, look at your unit's voltage trim and make sure that your all of your boosters are putting out the same voltage. Obviously, if you've got a massive layout or you have massive amounts of boosters and power districts, then you'll need to do this more than once. In my case, I don't foresee the need to buy any more additional power, not unless I start adding more operators somehow. So I don't see that I'm going to have any more than 2 trains, maybe 3 running at one time. And quite frankly, between these 2 power districts now, I've got more than enough power to handle all that. So we should be good to go. But just thought that might be useful to some of you out there. Once again, if you have any questions or comments, I know I kind of went through it fast and I don't think I skipped anything, but if something isn't quite working on your layout, you can feel free to give me a shout. And then obviously, as I continue to develop the operations with the distributed power and sort of the different consisting options that I'm doing, I will share that all with you. So once again, I hope this was helpful for you. If you got any questions, go ahead and drop me a line down below.